Etching gel is used in dentistry to enlarge the surfaces of areas to be glued. These can be either the tooth itself or usually ceramics and plastics. Unlike cementing, in the process of gluing, also called bonding, the surfaces to be glued are specially treated. Etching makes the surfaces of the tooth or ceramic inlay rougher, called a micro-retentive pattern. The animation shows a section of a tooth, white, to which etching gel, blue, is applied. The surface of the tooth is smooth, but the gel eats into the enamel and makes small lagoons and holes. These remain once the gel is washed away, and now the glue, green, is applied to the tooth and flows into the pattern on the surface, assuming the tooth remains clean and the glue is viscous enough. If the inlay is also treated in this way and then set on the tooth, and the glue is allowed to harden, then the gluing surface can be enlarged considerably. If you look at the original surface of the tooth with the inlay, you see a length of X. Looking at the gluing surface of the tooth after etching, the surface has been enlarged by a factor of Y. Since the etching pattern is not only 2 but 3-dimensional, the gluing surface increases even more. Etching conditions the surface of the tooth before bonding, which enables a stable connection. Good results are only possible if the tooth remains clean. A cofferdam should always be used. The animation shows what happens if, for example, saliva, shown in red, gets on the tooth. The porous surface closes and the glue, shown in green, can no longer flow in. The fillings or inlays cannot be sealed as tightly. Remember that not all of the tooth can be etched to the same extent. The animation shows a tooth from which the enamel is removed using a drill. Enamel is a mineral. Under this there is dentine. This consists of protein and small channels which are damaged by drilling, resulting in mush, called a smear layer, shown here in gray. The smear layer prevents the glue from flowing in, but if the etching gel is spread evenly over enamel and dentine, then the proteins released by the gel would form clumps, called denaturization, like chicken soup which starts to boil. The gray film on the surface consists of denaturized proteins. The glue could not get into the dentine. This is why the gel is first spread over the enamel and sometime later on the dentine, and left for only a few seconds. This removes the smear layer and creates the desired micro-retentive pattern in the enamel. The glue, in green, flows in without any obstruction, the basis for optimum hold. This is not just abstract theory, this is how it works in practice. The tooth is surrounded by the cofferdam, shown in violet, and has been ground for a ceramic inlay. Before the inlay is glued, both the surface of the tooth and the inlay are etched. The etching gel, shown here in blue, is applied to the clean tooth on the enamel first. The enamel is easy to see, in white, and under that the yellow dentine. A magnifying glass makes this even easier to distinguish. The etching gel is left on the enamel for a few seconds. You can see the dentist checking the work using a mirror. The discolorations in the dentine are from an old amalgam filling and do not need to be removed. The rest of the tooth is now treated with etching gel. The tooth is cleansed thoroughly with water and then dried. The enamel, the dentist points to it with a probe, now looks chalky white, a sign that the work was performed correctly.